Hello, we've got part two in this series about writing linear systems from paragraphs. And so a lot of what I'm talking about here has been talked about in the previous video. So I'm going to go through this one a little bit more quickly, just so you can see what's supposed to happen. So really what's supposed to happen in general is we're supposed to go from a paragraph to a linear system, and there's a hybrid system in between that has labels. We call that dimensional analysis, which should, if we learn how to do this correctly, help us to write our equations. For example, in this exercise, we know the perimeter of a rectangle, and we know the length is longer than the width by 3 centimeters, and we're supposed to find the length and width just with that information. Since I'm asked to find the length and the width, then I define those variables as centimeters of length and centimeters of width. And then my first sentence says the perimeter of the rectangle is 14 centimeters. So, as far as dimensional analysis is concerned, we're going to have 2 times L centimeters plus 2 times W centimeters is going to equal a total of 14 centimeters. The point of the dimensional analysis is to make sure that centimeters plus centimeters equals centimeters. In other words, the labels all have to match in order for equality to be true here. So, taking away the labels and simplifying, we end up with this equation, L plus W equals 7. This is simplified from 2L plus 2W equals 14, which is simplified from our hybrid. So we have the paragraph, or the sentence, and then we have the hybrid equation with labels, and then we strip it down to just the pure mathematics, and then we can apply mathematical techniques and tricks to solve the system once we get the other equation. The other equation here is really trivial in a way because it simply says its length is 3 centimeters more than its width. So here's what I'm going to do. I'm going to take the width in centimeters, I'm going to add 3 centimeters to it, and that will be the same as the length in centimeters. So the length is 3 centimeters more than the width. Strip away the labels to go from hybrid to pure math, and that is your system. Nice thing about this system is it's already solved for L. I just have to substitute W plus 3 in for L right here, and I can already see that the length is going to be, I thought I was doing this, yeah, the length is going to be 8, and the width is going to be 3 less than that, so no, that can't be right. Anyway, you can solve that one later. Sorry for the stammering. Another example, this time we're talking about cheese, and we're trying to combine 2 different cheeses that have high and low fat content. We're trying to create, again, a hybrid cheese that is sort of in between. So the first question was, how many grams of each kind of cheese must be mixed? So that tells me what my variables are. My variables are going to be in grams. X grams of fatty cheese, Y grams of low-fat cheese. And we're supposed to mix X and Y, these two different cheeses, together to get 30 grams. That should be the easy equation. X grams plus Y grams is 30 grams, straight up. So again, dimensional analysis says grams plus grams have to equal grams. It all works out. The other thing here, just to recognize, when we have this equation, you need to realize that there's so many different solutions. For example, 1 gram plus 29 grams, 15 grams plus 15, 10 plus 20. We could have a half a gram and 29.5 grams. So there's infinite ways that we could combine 2 different types of cheese to make a 30-gram mixture. But what we want is not just a 30-gram mixture. We want a 30-gram mixture whose fat content is only 30%. So more than the low-fat, but less than the high-fat cheese. So here's what I learned from just looking at what 45% means. Percent means out of 100, so 45 out of 100. When I say 45% of the cheese is fat, that means for every 100 grams of cheese, 45 of those grams are fat grams. In other words, 45 fats per 100 gram, or 0.45 fats per gram. It all depends on how you want to look at it. But this is, in fact, when you see 45%, you need to understand, look at that percent, that's a little ratio. It looks like the same thing we use for labels, something out of something. Anyway, so a percentage is a rate. Whenever you see a percentage, think rates. And so here we have another rate. 20% means 20 fats out of every 100 grams of cheese. So if I take X grams of cheese times 45%, that's just going to give me, well, the grams are going to cancel, and I'll be left with fat grams. Here, 20 fats over 100 grams times Y grams, again, grams divided by grams, that's just going to give me fat grams. I need 30 fats out of 100 grams of cheese, in other words, 30% of 30 grams. 30% of 30 grams, again, grams cancel, and I'm left with just fats. That's the hybrid form. We get rid of the labels, and then we can do some simple algebraic tricks. For example, we can multiply both sides by 10, so we can get nicer numbers to deal with, and we could even double those to get completely no fractions in our form. No matter which one you use, you should still be able to get the right solution to the system that's shown here. So once again, I'm not solving the systems here, I'm just spending the time setting them up. Here we have condominiums, and we need to know how many of the one-bedroom and how many of the two-bedroom condominiums were there, given the fact that we made about $7 million in sales, and also given the fact that there are 50 condos, and $120,000 per condo is the rate, and $150,000 per condo is the rate for the more expensive rooms, the two-bedroom ones. So this is just like 45% of the cheese, 25% of the cheese, 20% of the cheese, whatever. This is a rate of change, just like 45% is a rate of change. This is 120,000 per condo. The other one was 0.4 fat grams per gram. Rates are rates are rates. As long as you can identify a rate, then you should know how to use them. For example, $120,000 per condo times X condos, which I don't know how many there are, but I know that there are X of them, and if I have multiply by that rate, that's going to tell me how much money I made, because condo divided by condo, those divide out, and we're left with just dollars. We add that to the money made by selling the Y condos, and again, the condo divided by condo, leaving us with just 150,000 Y dollars, and that's going to equal this huge number. Let's divide everything by 1,000, get smaller numbers, divide everything by 10, get even smaller numbers, and divide everything by 3 to get the smallest numbers possible. Again, this is so that I have an easy equation to work with. We go from paragraph to hybrid equation to math equation to simplest equation. You take the simplest form and work with it to make your work easier. Finally, we have the classic boat speed, or person speed swimming in a river, upstream, downstream. This is the same as a plane flying with the wind or against the wind. The important thing to be able to understand this is when you're swimming with the current, your speed is how fast you can swim plus the extra push that you get from the current. And that is in miles per hour. So we have our speed of the current in miles per hour, and we have our own swimming speed in miles per hour. If we add them together, we still have miles per hour. According to the paragraph, what we did is we went that fast, which was enabling us to cover 15 miles in just 3 hours, which is 5 miles an hour. Similarly, if we're swimming against the current, then no matter how fast we're able to swim, the speed of the water is going to take away some of my speed. So we have the speed of my swimming, we have the speed of the water, and the speed of swimming is reduced by the speed of the water by however fast the current is in miles per hour. And we took 15 miles, 5 hours to swim back up. That means 3 miles per hour, and this is a very simple linear system. Now, some people use their dimensional analysis this way. They actually use distance equals rate times time, and you can end up with 3 hours times b miles per hour plus 3 hours times c miles per hour is a total of 15 miles. In other words, spending 3 miles with our rate plus the river rate, that should give us the total distance traveled. Taking away the hybridization and just looking at the math, it's a nice clean 3b plus 3c equals 15. Notice if we divide everything by 3 hours, we're going to get b plus c equals 5. So this is the same system. Here, 5 hours times the speed swum less 5 hours times the speed of the current is going to equal 15 miles as well. So again, we divide both sides by 5 and we end up with the exact same system that we saw before. Hope this was helpful. Have a great day.